Hi everyone, my name is Antonio. I'm a senior FAE in PDIC. Thank you for joining us here. Today I'm going to share with you how can ultra-wide input DC-DC simplify your designing. And here's my agenda for today's topic. I will show you all the benefits of using our ultra-wide input solutions. During my presentation, if you have any question, please feel free to leave a message. We can have discussion at the end of the webinar. In half brick and quarter brick package, we know there are 2:1 and 4:1 ratio of input range of DC-DC converters, which are very common in the market, and they can be widely used in different fields. There are communication, automation, defense, renewable energy, railway, etc. Railway application will be the main focus today. According to its regulation, EN 50155, there are 24, 28, 36, 48, 72, 96, and 110 different systems. But of course, we also see multiple input system demands in different fields. From the railway standard, EN 50155, we see it has high requirement in supply voltage with wider deviation and transition from 0.6 to 1.4 times of nominal input voltage. So the 2:1 of input voltage ratio is not able to fit this requirement. That's why we designed 4:1 for railway application. We see the input range 9 to 36, 18 to 75, 43 to 160. Those models are most common in global railway systems. How to manage all the systems is a big task to engineers, especially for international enterprise. To satisfy all different input systems worldwide, it needs to develop several power boards. This will take plenty of time and cost of engineering. So we developed the ratio of 8:1, 10:1, and 12:1 ultra-wide input solutions to simplify the process as our main purpose. In recent years, we've launched several series from 40 watts to 200 watts. The input range 14 to 160 can cover 24 to 110 systems. That means we can use only one single DC-DC converter in your system to cover different systems from global demands. It will reduce much unnecessary time and efforts you need to invest. That's one of the benefits for you. The ultra-wide input solution not only can be used in railway applications, in other applications like defense, forklift, often use 12 or 48-volt battery systems. We have 9 to 75 input range. They can cover no matter voltage dip or surge during operating. It's no need to worry about the equipment could be damaged or adding many extra components to protect the system. These are our ultra-wide input DC-DC converters from 40 watts to 200 watts. They are QAE 40U, 60U, 100U, HAE 150U, and 200U. This series features industry standard package and pin-out, 3000 VAC isolation, 5 to 53 output voltage, as well as enhanced hold-up function. Enhanced hold-up function is designed to help engineers to deal with S2 and C2 requirements in railway system. That make choose capacitors easily or even reduce the capacitance, volume, and cost. I will introduce later regarding how to use this convenient function. Standardized product package is something that we are continuing doing in developing new products. It's not just make it simple for you to design PCB layout, but also we have considered the possibility of upgrading system with higher power that engineers can use the same pin layout to redesign. And using brick type can bring good flexibility in application, especially for thermal solution that heat generated from the components inside can be dissipated through the base plate of the module. Also, through assembly heatsink or mounting the DC-DC on the system chassis can efficiently improve the heat dissipation. We see ambient temperature is a big challenge in railway application as well. According to the environmental conditions in EN 50155, mostly will use 70 degrees to meet the requirements, which are OT3 and OT4. The extra 15-degree temperature rising for 10 minutes, that is OT1. That shows the importance of brick type and its base plate. Besides, conversion efficiency of products is very crucial. The QAEU and HAEU series provide up to 72% of efficiency. We know high conversion efficiency can reduce power loss, also reduce generating the heat to improve product reliability further. For HAEU series, their output power is up to 200 watts. Not only that feature high conversion efficiency, but also we improve the base plate for better conductive cooling performance in order to obtain a better safe operating area of our products. First, we will introduce the best application circuit of HAEU series, including some special feature pins such as bus out, and UVO pins. In order to make HAEU still keep high efficiency at ultra-wide input range, at least a 150 microfarad capacitor should be connected to the bus pin and to maintain the stability of the module. Because of its special topology, it can provide higher charging voltage to hold up capacitors when operating at low level of input voltage. So lower capacitance can be chosen. UVO pin provides adjustability through input voltage to enable or disable the module. It can be done by one single resistor to avoid the module activates the output at unexpected input voltage. The pulse-out pin can provide 12-volt 1 kHz square wave signal. This signal can be used on the inrush current limit circuit. Using capacitors in any application circuit like filter, hold up, both will generate huge charging current while applying input power. If the energy is high enough, it will blow out the fuse or make the equipment at the front stage get into protection mode, like OCP or SCP. The easiest way to limit the current is to use a resistor or NTC. But that might not be a good idea because the resistor can dissipate high power loss in this application. The circuit here is to take advantage of the MOSFET's ohmic region to achieve the same effect. During the short period of time after applying input power, MOSFET acts as a resistor to limit the current rising. Then there will be the minimal power loss when fully turned on. The impact on the overall performance of the system is quite low. Generally, the signal source can be provided by an additional 555 timer and install some discrete components for IC's VCC. In contrast, the pulse-out function can save this part. Here's the result of the inrush current we tested. The left side is the case without any additional parts, and the right side is the inrush current limit formed by the pulse-out signal. The difference between the two is higher than 100 amps. It is also possible to obtain a lower current value by adjusting the peripheral parts and selecting higher level of MOSFET. Supply interruption and changeover will bring huge impact as well. Both demands will cause voltage interruption at the input. S2 and C2 are the best requirements, and the conditions of S2 must meet criteria A. Criteria A means that the product must have a normal output when working under the required condition. Criteria B allows temporary degradation, which is self-recoverable. Therefore, for the conditions of S2 and criteria A, hold-up capacitors must be added at the input. The selection of the capacitance and rated voltage of these capacitors are affected by the charger voltage, which comes from the input voltage. The enhanced Hall function of Haeu increases the charging voltage of the capacitors, increasing the original charging voltage of 24 volts or 48 volts to nearly 80 volts by connecting to the bus pin. It reduces the capacitance it needed due to connecting to the bus pin. It can turn the multiple and complex selections of the capacitors into 3 types. Although Haeu can simplify the whole capacitor to only 3 types, but how about simplifying it into 1? Haeu simplifies the using way of the bus pin. When there is a need to hold up, you only need to connect the capacitors to the bus pin. When this function is not used, you don't need to install a capacitor to keep it stable, just leave it open. In particular, the bus pin provides a low and stable voltage, about 21 volts, regardless of whether it is 24 volts or 110 volts of input voltage. The bus pin maintains a fixed voltage. The capacitors connect to the bus pin, the rated voltage and capacitance won't be affected no matter input voltage changes. Thus, it can achieve a single and complete solution. Here are two examples show how connecting the hold-up capacitors to different positions will affect the capacitor selection. When connecting the capacitors to the input, the charging voltage is rely on the input voltage. So the selections of the hold-up capacitors are different in each power system. This is a pity for engineers who selected ultra-wide input range DC-DC converter, but is still not able to integrate the power board into a complete solution. By using QAU series product, charging the capacitors through a fixed voltage from the bus pin to get only one type of capacitors. This configuration may increase the capacitance but remain the same volume with a lower charging voltage. From this curve that we see, using QAU, enhanced Hall function can face the same capacitance, rated voltage, volume, and most importantly, to control the cost in each different system situation. With the perfect integration of DC-DC converters, hold-up capacitors, EMC filter, and all other components, we can reach a single power board purpose. Through above introduction, now you know the ultra-wide input range DC-DC converters with enhanced hold-up function can really save time and money for engineers. Our DC-DC converters can save up to 60% of cost and volume on the hold-up capacitors, compared to other similar products without this function. This brings great convenience when designing multiple systems. Both HAEU and QAEU are ultra-wide input range with enhanced Hall function. It's not only to help engineers to accomplish the development of the system in the shortest time, it can also reduce the types of inventory, simplify the procurement and management of the materials. The original demand for 3 power boards can be reduced to 1, shorten project schedule, and speed up new product launch. This is my sharing today. Hope you like it, and let me know if there is any question. Okay. The first question is, does the bus pin of QAEU or HAEU needs to be connected to the capacitor when not in use? These two series use different topologies. There is an extra boost circuit inside HAEU, and because of the internal space, it will require external capacitor to stabilize the topology of boost. And QAEU is designed with single topology. So when the bus pin is not in use, just leave it floating. And the second question is, what should I do? Oh, sorry. Number 2 question, should the whole capacitor on the bus pin also require the diode is being present at the input being pin, so the energy of the capacitors is not drained by the show during S2 testing? Yes, the diode should be connected to the input side, because we know the test of S2 is the power source will be short circuit. So to prevent this situation, we should put a diode to prevent this situation happen. And the question number 3, what should I do if the required output voltage is not found in the specification? Both our QAEU and HAEU series provide trim function, which can increase the output voltage by 10% and or decrease by 20% with a single resistor. If the demands is not still not met, we also provide customized services. Next question. If the customers encounter EMI problems, what will you do? First, we will provide customers with suggested EMI solution, including wiring and layout. Of course, there will be difference between the conditions of customer system and reset in our company. That may cause different test results. After checking customers' conditions, including input and output, installation, and so on, and we will follow the conditions and provide the countermeasures to the customer as soon as possible. Sure. Then next question is, we require a 500 watt system input, 20 volt and output 60 volt. For this question, 500 watt system, I think we can discuss it by email, okay? So if no more question, thank you for joining us today. Thank you very much.